Another DraftScience video presentation. I guess we're just going to have to keep doing this until there's a concession. So it's just more on the fact that the kinetic energy formula is just junk science. It's not, you shouldn't even call it pseudoscience. It's so disconnected from the regular process of how things are established in physics through experimentation and scrutiny, and none of that took place. It was just a bandwagon, and people just jumped on it, and they didn't really care about proof. Okay, so a couple of experiments fool people. Okay, simple experiments. I take the same spring and I shoot an object into gravity. The heavy object, okay, twice as massive, goes a certain height. If I take something that's just half the mass, not tiny, just half the mass, and I put it on the spring, it goes 4 times higher because it ends up with twice the velocity. And it goes 4 times higher. So that looks like it's more energy, but if I let it fall back on the spring, it'll fall back on the spring with exactly the same amount of energy. Nothing different really happened. It's the same spring, the same energy. If I take an arrow, a crossbow, and I pull it back a certain amount, there's a certain amount of energy in the bow. All right, I put a heavier arrow, a twice as heavy arrow in, it goes half as fast when it leaves. These are just simple basic rules, and the fact is if I was to catch those arrows, think of it like a catapult. I have a catapult, I crank it down, and then I shoot a heavy boulder. And then I catch it with another catapult. Well, the catapult goes down just as much as the other one was down, theoretically, if I can perfectly exchange. Now, it won't be perfect, but whatever. Let's just say for the sake of argument, the sake of an illustration of an experiment, that I did successfully transfer the energy. And now I just take the heavy boulder off and I replace it with 1/2 the size. The 1/2 the size will go twice as fast. It doesn't have twice as much energy, the same mechanism through both boulders, the same amount of energy produced the transfer of the energy. There's just no rational argument for saying the lighter boulder has twice as much energy. It doesn't make any sense. It's just garbage. It's silly. It'll never work in any real experiment. It'll never be collected by anybody. Nobody will collect the twice as much energy that the smaller boulder has. They'll have no catching device, right? There's 2 boulders coming at you. One weighs twice as much and is going half as fast, and one weighs half as much and is going twice as fast. Well, you get it. One's heavy, okay, and slow, and one is small and fast. And they're coming at you. Their theory is that this one over here has twice as much energy. Now, the trick is, what device could I possibly create in the universe to catch them, to collect this extra energy? Will there be any device I can make that will actually be able to get more energy out of the smaller, faster thing? Can I make any catcher that'll say, yes, this is 500 watts, and this is only 250 watts? Is there any device that will produce that outcome? And the simple argument is no. Now, I can't do an experiment that can't be done. I mean, obviously, I can't make the device they can't even make. So until they show me somewhere where they made this catching device that caught this extra energy, that actually made it visible somehow, that actually produced it, that actually toasted more toast. They toasted more toast with the faster, lighter object than they could toast with the heavier, slower object. This will never happen. I will never be shown this experiment. And that's the whole point. That's the proof here. They can't ever show you because it's ludicrous. It's silly. It's absolute nonsense. I shouldn't have to make this argument. And then they're so insulting to the truth by implying that somehow Newton believed in this fake energy, that he had any notion of its existence at all, that he thought at all this made any sense. No, all of this crap was invented after Newton was dead. Well, mostly. And clearly the conversation wasn't in Newton's realm where conversation takes place. So let's say the conversation started while Newton was still alive. It started in places Newton wasn't hearing it. Okay, because he didn't make a statement on it. But clearly it has nothing to do with anything Newton believed. Okay, and they keep saying F equals ma. But that really is just saying F equals mass, because Newton knew that. Okay, he knew the acceleration is the same for any objects. Okay, the piece of chalk, heavy battery. He knew they fall at the same rate. They have the same rate of acceleration. So the acceleration just ends up being a constant. It doesn't mean anything. All that really matters is your mass. That tells you how much force you collected. The heavy object collects more force, falling exactly the same way, and that's why the heavy object, when it hits the ground, makes a much bigger bang and there's a lot more work. Is because it has more energy. It has more momentum. Okay, there's no this is much heavier because it's, has much more energy because it's going faster kind of notion. It's always just about mass being just as important as your velocity. The two things are equally important. There's no velocity really important, mass really unimportant. And clearly Newton saw mass as the only way you derive something called momentum or power or ability to do work. You have to collect the velocity on a mass. Anyway, all right. There's no evidence that Newton thought there was anything else involved but masses and velocities. And that's all there is. There's no velocities squared and masses halved. So let's go back to the original, where it became obvious to me, okay, that physics has huge, glaring, gigantic errors in its reasoning and logic skills, was the physics girl experiment, if you want to call it that. So you have a train. The train has one mass unit and is going 2 velocity units. You connect it to another train. So you have another train plus the second train. Okay, so this is this train. This train connects to this train. So now you have 2 units of mass, and what you're going to end up with is 1 unit of velocity. Now, that makes perfectly good Newton sense. Newton would say, yes, I have done the circumstance correctly. And Newton would say these two things are equivalent in anything they're doing that might be called locomotion or energy or whatever word he might use. Will to move, whatever, that I have transferred the will to move into this collective object. I have exactly the same amount of capacity to do work here as I have here. It doesn't matter what form I put it in because I've inverted the masses and the velocities and I have the same total amount of stuff. So if this was 30 joules of energy, and it is convertible into joules because it has velocity, which is meters and seconds, and it has kilograms. So it has all the units you need to decide it's an energy. Okay, and this has 30 joules. Now, the argument is when you use the wacky, silly, badly composed, silly historied nonsense formula of Newton's most hated enemy in life, right? The guy who was the biggest pain in Newton's ass, who was a thief and a liar by Newton's description, that individual's formula, okay, says this has, let's just use, we could say this has 100 joules and this only has 50. So somehow, when I transferred the momentum, I lost half the energy. So, and it's half the energy. It's a lot of energy. It's not like, oh, it lost a little bit to some kind of, it hit a bird. No, it lost half the energy. So understand, if it's a 1-ton train and it's moving 30 miles an hour, right? Now it's a 2-ton train moving 15 miles an hour. They're saying half the energy of that train was lost. I mean, it's a huge amount of energy. It's not like a little tiny, oh, it made some noises. All right, so just understand in theory that we know that when this transfer happens, even though we have nice Velcro here, that there's the odds are we're not going to be able to do this 100% perfectly. We're not going to be able to bang the two things into each other so perfectly that all of the transfer is perfect. Just if we were trying to transfer heat from one object to another object, and we had 10 degrees here, and then we had something else that was 5 degrees here, and we tried to get this heat into this object, we connected them. We're probably not going to get a perfect transfer. We're going to get some stuff leaking out, okay? And so we're not going to end up with the two of them will come down to 7.5 or something. They'll both end up the same temperature. And see, that's another point here, is that it's really hard even to transfer heat completely into objects that have different thermal capacities, let's say. They'd start with to give them different amounts. All right, you can only transfer it from zero. So if I took the heat that was in this 10 thing and I put it in something else, and then I transferred it to the two objects, I'd have a much better chance of transferring it if I put it in some other form. Well, anyway, you can use other analogies is the point. All right, so the simple argument is that I think anybody who has any, like even grammar school sense about how physics works knows that if I transferred 100%, that is, if this actually leaves at 1 V, okay, a complete 1, not 0.9, not 0.87, but the full 1, that I had to transfer all of the energy perfectly. Like it had to happen in space or something. I can't make wind. I can't make sounds. I can't toast some toast, right? I can't heat your dog's, bed. I can't do something else. I can't make energy go somewhere else and do something else and then say, no, I transferred all of the energy. So if I lit any light bulbs, played any records or MP3s, if I did anything else with the energy, I couldn't have gotten this velocity. I have to get something less. And that's what we just say, those are acceptable and understandable losses. But again, their theory says we lost half the energy. Not, oh, we made a little bit of sound, and we smushed a bird and we did this and did that. No, half the energy was lost. They're pretending somehow this thing has real twice as much energy. That it's some sort of real kinetic energy that has a real extra amount than this has. Even though, again, if I made a bow and I just, and I'm going to shoot the bow, okay, I'm going to shoot the arrow, we know the bow produces the same amount of energy, and I put a lighter arrow in, I'm going to get a faster bow out. I'm going to get the arrow's going to go twice as fast if it's half the mass. If it's 1/2 the mass, it's going to go twice as fast as one that's, twice as heavy, and it's going to go slower, half the speed. And it's because this tells you this system has energy in it. The system has an amount of energy, an amount of joules, 100 of them or whatever. And you're just saying, look, I'm going to transfer it. And maybe only 98% of the energy will go into the arrow. But it'll be 98%, okay, for both of them. It'll be 98% of the energy goes into them. They will have the same amount of energy. Yes, one's going faster, but it's lighter, just like in gravity. The lighter thing you put 4 times higher to get the same momentum out of it. The same velocity. No, well, you want twice the velocity for something half this much. So to get the same momentum, I have to go 4 times higher with something that weighs half as much. Well, that's a trick of gravity, but there's no tricks here. This is just an absolute nonsense. Half the energy lost, and they say this is rational. When this is the Newton half, okay? Just understand, this is what Newton would say, okay? Same energy. All right, yeah, you lost a little tiny bit, so okay, this is 29 joules. All right. But you can't make this argument you lost half the energy somewhere. It's just silly. There's no reason for it. It doesn't make any sense. It's totally illogical. Why do I have to argue this? I mean, why isn't there universal understanding that, yes, of course, that's the way it works. How could it work any other way? You can't make energy. So again, the scenario would be if I reverse this, okay, by using some mechanism to collect the energy. And I took a heavy object, okay, you know, the catapult, and I shooted the boulder into another catapult. So the catapult was up here, and I'm going to compress the spring on the catapult by catching this boulder. I'm going to catch it. And now I shoot a lighter boulder. Their argument is this boulder only had 50. You'll use their thing, joules. But they're going to say that the light boulder, okay, so the boulder, the heavy boulder that compressed, okay, the catapult, only has 50 joules. But the light boulder I put on top of it and then shoot back to this spring somehow has 100 joules of energy. But the trick is, it's only going to compress this catapult the same amount it started with. The first shot, it's going to only compress it the same amount. It's going to be a little less because of the losses, but again, we're only talking about a tiny percentage of the loss. We're doing this really in a thin atmosphere on top of a mountain, you know, whatever. So there's very little losses. How can it make any sense? How can you claim it has 100 joules, that it has twice as much energy as the heavy rock that was going slower, that, you know, compressed the catapult, and now you say the lighter rock has twice as much energy, but when I test it to see how much energy it has, I let it land. How come it doesn't compress this catapult anymore? It doesn't go down any further. It doesn't make any extra energy. So this can't be real. And of course it doesn't even make any sense. How can I step on a scale, okay, and it goes down to, it says 100 pounds, right? Well, let's say it says 50 pounds. And then I put a lighter person on the scale and it shoots them back at 100 pounds of energy, right? You know that can't happen. You can't just make extra energy. You can't just, because I have a spring and I compress it, and because I put a light object in front of it, the spring now has 100 joules, where if I put a heavy object here, it only has 50 joules. How could it possibly? That doesn't make any sense. Somehow the spring, this is another one of your weird entanglement theories. Somehow the spring knows I put a heavy object in front of it, so it knows, oh, I'm only supposed to shoot at half as much energy. You know, the heavier the object you put in front of my spring, the more my spring says, oh, I'm not supposed to really push it hard. I'm only supposed to push it a little bit. And if you put a light thing, I'm supposed to push it really, really hard. You know. Does it make any sense? No, it doesn't make any sense. It's absolute nonsense. I don't know why there isn't 100% agreement by every single person watching these videos saying, yes, physics made a boo-boo. Mistake. Whoops. Whoops. That was a stupid bandwagon to jump on. Newton was right. Leibniz was kind of a silly person. And, you know, and he could have been a crook and a liar too, but, you know, we don't have all the evidence. But clearly he had great incentive in damaging Newton's character, in damaging Newton's physics. He had a huge incentive to do that, and so did the entire nation of France and Germany. France and Germany, okay, they looked very lame because they couldn't make any good physicists, okay? They couldn't do it, in Holland, or wherever the douchebag fiddle brain was. Huygens. Okay, Huygens. So, it was Holland, right? Or something Dutch? I don't know, whatever. Yeah, I always confuse these Holland and Dutch. I don't know why. But anyway, so it was whatever, Dutchland, which is part of Germany, right? Deutschland. Well, anyway, let's just not get into it. But clearly they all had deflated egos, okay? Their physics wasn't as cool as England's physics. They didn't have the great and powerful Faraday and Newton, and so they felt all lame and weak, okay, and pussy. And And so they were trying to create some fake physics that could make them somebody, you know. And that's all the story is. And you've all jumped on the fakers, you know, the Trumpers. The I'm a self-made great man. Okay, so it's kind of like a Trump. You're all just little Trumpers with, you know, you'll have to inherit your muscle. You know, you can't punch anything with anything but your grandfather's fist. You know, you're such weak pussies. You know, you have to show up at the gunfight with a machine gun. You know, you're just pussy shit. And so you're all defending the pussy shit physics. You know, the overt attack against the guy who did all the experiments, was terribly meticulous, wrote everything down, very careful, very, you know, millions and millions of pieces of paper, you know, and everything, you know, you have to give a guy credit. I mean, he spent his whole life devoted to this shit, and you're spitting on him. And then you're insulting him by showing, oh, it's Newton's theory. No, this isn't Newton's theory. F equals ma is no excuse for creating this absolute fake nonsense, okay? I mean, they're telling you that because F, the force, equals the acceleration, where in gravity it's the same acceleration for an atom as it is for the Earth. I mean, if I put an atom in space and the Earth is in space, the amount gravity is moving them, the velocity gravity is giving them, is exactly the same. So acceleration is just couldn't be more, you might as well just say constant, times mass. And that's all it is. The force is completely proportional to how much mass you have. The more mass you have, the more force bucket you have, the bigger your bucket. So if you want to collect more force, have more atoms. The more atoms you have, the more force you collect. You collect 1 force unit per atom, 1 force unit per atom, 1 force unit per atom. So if you have 3 atoms, you collect 3 force units. If you have 1 atom, you collect 1 force unit. That's all this is saying. Somehow they perverted this because they've decided that, okay, well, F equals ma. Well, that means delta T. Okay, so we'll do this little delta crap. That means delta D over delta T. And, well, it's the initial delta T, okay, so you have the first time, the initial, okay, so that's V initial, and then you have V later, and, well, we'll just multiply those times each other. Yes, you had $5 yesterday, you have $5 today, therefore you have $25, right? Of course. You had $5 in your pocket yesterday, $5 today, that means you have $25. That's the only way you can pervert this, is they completely perverted it. This simple statement, F is really proportional to M, okay, how much force is proportional to how much mass, they turn that somehow into, let's take the velocity and square it, and let's put a half later, right? 100 years later, they decided to sneak this little half in there. It clearly wasn't a derivative of Newton's formula. It wasn't invented as a derivative of Newton's formula. So they're just lying overtly to say, oh, it's a simple derivative of Newton's formula. No, it isn't a simple derivative. It's a bizarre, strange, insane derivative of Newton's formula. Here, Newton's pretty much saying force and mass are everything. And now you're saying energy is all about velocity. You know, and mass is irrelevant. Nearly irrelevant. All right, so I've just been over this so many times, and it's just, how can you, can't you understand that I cannot possibly have a certain amount of momentum? You know, it's a real amount, like I have 4 momentums. I'm going to now transfer. I can't transfer all the 4 momentums and then say, well, and some of the momentum went over here, and some of the momentum went over here, and some of the momentum went over here, and it went over here. I can't transfer 4 momentums and then say there's a bunch of momentum that got away. You can't do that. It's physically impossible, and and they have it as the cornerstone almost. It's one of the cornerstones, like their silly two-slit experiment and their silly bent space. It's a cornerstone of their physics, and it's nonsense. I just shouldn't have to keep doing this. I really shouldn't have to keep doing this. I just shouldn't. It's an obscenity that you're this belligerently scummy, liey, crappy, shitty. So I don't even know what side this guy's on. Mitch Welsh. I interpret Newton's second law to represent some force that would alter the momentum of a body. So yes, of course, acceleration means your momentum's being altered because your velocity's being altered. The force isn't going to alter your mass, so it can only augment your mass by moving your mass with a velocity. But we know that any force that we know of, okay, that it affects the mass, and that's it. So however much mass you have is how much force you have. So the two are directly proportional. Mass increases, force increases. It takes more force to move the Earth into the sun than it takes to move one atom into the sun. Right? The force on one atom would be a 1, let's say, we called it 1, the amount of force. Well, then obviously the Earth would be 1 gazillion times 1 in the terms of the amount of force acting on the Earth. Like if I were to push against a train going at a steady velocity, resulting in it slowing down. So you're decelerating it by imposing your momentum on it. So you have to transfer your momentum to it, okay, to cancel its momentum. All right. But again, the force would be in your momentum. It would be how many atoms you have and how fast they're going. Those are the two components you're going to give the train. And you know, if you did it in space, that's all the equation would have in it. There would be no kinetic energy formula used. It would just be momentum. It's two competing momentums. And that'll give you exactly the correct answer as to how much you will slow the train down. If you have one atom and you're pushing against it, well, then you need to have a very, very high velocity to slow it down. But if you're 100 million atoms, you don't need much velocity at all to slow it down. Moving into the subject work, this guy has a way about him that I probably aren't going to like. The idea is supposed to be, no, the idea is the history I already gave you. This has nothing to do with anything Newton believed. This has everything to do with pseudoscience that took place in France and Germany. Okay, that it tells the total force. Okay, the idea is supposed to be that it tells the total force added to the system. The idea is that it tells the total force added to the system over a particular distance. Of course, yes, that's all you're saying. You're saying, I'm going to interfere with something. It has momentum arrows going this way. I have momentum arrows, let's say, going this way. Well, some of my arrows have a component going against that velocity, and so I'm going to start degrading it in that direction, and I'm also going to be adding vectors in this direction. Yes, you're just adding the momentum vectors. There's no kinetic energy formula necessary at all. Completely irrelevant. Okay, so get to the kinetic energy part, buddy. We already know momentum works. It always works. So again, that's another thing I keep saying to you people. Show me one experiment on Earth where the momentum formula is giving you the wrong answer. That somehow the answer is erroneous and incomplete and you can't rely on it. Show me that circumstance. Show me any experiment where just following the momentum doesn't work. Okay. I mean, that's the irony of this. It's so ludicrous, right? You had a formula that worked perfectly. Descartes and Newton give you, and Galileo give you mass and velocity. Works perfectly. And somehow we need to make a new formula? It works perfectly. Okay, except if you don't understand that gravity, if you're too stupid to understand that because it goes 4 times higher doesn't mean it has 4 times the energy. It's light. It went faster. When it lands on the ground, it's not going to make more energy. It's not going to make 4 times the impact. It's not going to do any of that stuff. And they thought it did because of one experiment with clay, right? Okay, clay deceives you because clay yields to fast things. The faster the thing's going, the more the clay says, I'm getting out of the way. Obviously it doesn't do that, but I'm just saying the chemistry and the physics is that's essentially what clay does. Clay just says, if you're going really fast, I'm getting out of your way. All right, anyway. And that's all. There's no other experiments. There's no other anything, okay? It's just a complete sham. It's garbage, junk, trash, silly physics. The experiments don't demonstrate it. Even the one cited by whatever her name was, the woman, right? I found that when people actually redid the experiment, she dropped pieces of wood into water and, measured how far the wood went down as a measurement of momentum. And actually, when people redid the experiment, she wasn't even accurate. She didn't even get the right answers. All right. The problem is it does not give the momentum gained, but the kinetic energy. So again, what does this mean? That's an exact perversion of reality. So F equals m, that proportionality. Okay, yes, your acceleration. Well, the acceleration is always the same. So how is that relevant? Somehow is a justification for squaring the velocity and having the mass. No, it isn't. Lastly, well, this wasn't much of an argument. We know that kinetic energy and momentum do not predict the same speed. Kinetic energy isn't predicting a speed. It's predicting an amount of joules of energy that you can somehow extract. It's saying the speed is squared. It's saying the speed has twice as much value. I don't know if it's really predicting a speed, okay, but yeah, I suppose you could use the kinetic energy formula. Well, I won't venture a guess at how you're manipulating the formula to predict speeds, but whatever. When we create a hypothetical demo effect for marbles. So, again, if you create the hypotheticals, all you're doing is removing the insignificant losses. A little bit of heat, a little bit of sound, a little crushed bird, blah, blah, blah. You're just getting rid of the superfluous little stuff that just doesn't really have any meaning, okay? And you're just trying to get to the crux of it, which is your kinetic energy formula predicts that half the energy was lost. And by the same rationale, it means that I gain energy by just putting a lighter arrow in the bow. By putting a lighter arrow in the bow, I make the bow more powerful. That's the simple implication. It's nonsensical. A little kid could understand how that can't make any sense. The bow doesn't know I just put a lighter arrow in front of it. Now it's supposed to push harder. It doesn't know to do any of that bullshit. I mean, this is as bad as their silly photons deciding to split in two nonsense. I mean, it's just too silly. Okay. There are experiments which show, okay, so I already saw this experiment. It's terribly done, so that's why I didn't play it, because it's just crap. And it doesn't really do the different size object thing in any kind of way that could be useful again. It's just not useful. And it certainly doesn't apply the kinetic energy formula. So it doesn't make the direct assertion that half the energy was lost. So because it doesn't do any of those things, it's not very useful. But I'll show it just because I'll show how, well, let's do it. It's just such, it's so poorly done that what's the point? I mean, this is I could do the experiment this bad. What the hell is it? Get rid of this. No, don't try it for free. Oh, don't do that. No, I don't want to try it for free.
Experiment 4 is tricky since ball A and B begin connected to each other. However, since at the moment...
All right, so they're measuring it based on starting their iPhone when they push it. I mean, just terrible. The objects are bouncing back and forth between the mirrors. I mean, the rulers. It's just terrible. So what this
collision, all three objects did not collide. This is also considered an inelastic collision.
Right, and all they're doing is calling things elastic and inelastic. And so they had a thing right here in the beginning saying we're not using the kinetic energy. This equation is only being used to prove that it's an elastic collision is an elastic collision is an elastic collision. So they're just using the 1/2 mv squared, not to define the actual energy, not to even make an assertion about the actual energy, only to say that, look, when the two formulas disagree, therefore it must be an inelastic collision. No. No. So that's just nonsense. So, like I said, there's nothing to be learned from this because it's...
As the balls collided, each ball's final velocity was slower than the one before it. This is due to friction.
Right. So what good is the experiment? I mean, you actually lost all the velocity by the time you got to the fourth object. So you've lost so much to friction, and you gave them so little energy going in that they lost a huge percentage of their velocity to friction. Obviously, the more energy you put in, the less the friction is significant. So if they would have done the experiment with more energy in, they would have had less percentage losses to friction, and you'd be illustrating something a lot better. But all of this is conservation of momentum. So none of it has anything to do with the kinetic energy formula. So I'm just establishing, you saw the note, this has nothing to do with making the contention that there's twice as much energy anywhere. Okay, so I'm just saying another really irrelevant citation to a video that proves nothing. Nothing at contention. The contention is just this simple argument. The Velcro trains, I can show you. I can show you somebody banging the lighter train into another train, train of the same mass. The two of them stick together and they go off at half the velocity. I can show you that experiment. All right? And it's just claimed that, yes, okay, for the sake of argument, it's a perfect transfer. When no, we know that it can't be perfect because even the little plastic trains are going to make some sound and they're going to move some atmosphere, so the two trains going off do go off at a little less than half the velocity. Some of the energy, some of the momentum is in fact lost to the environment. But that's the same thing as saying the energy lost to the environment. You can't have something where you say momentum lost to the environment is different than energy lost to the environment. They're both the same thing. So you can't have twice as much of it leaking out and then say only this much leaked out. But this much also leaked out. You can't do that. All right. So there's the experiment. These are experiments which show. So the experiments really don't show much. They're done so badly that you're almost better off just drawing it on the chalkboard than to actually do the experiment that badly. But certainly that momentum is conserved. Well, obviously it shows that momentum isn't conserved in the sense that clearly a momentum was lost in all of those experiments, a lot of it to friction. So the transfers couldn't be seen as they actually would take place in space. They could only be seen as you're really degrading the velocity over time. So in a sense, it almost gives you the wrong impression. The last object leaves so slowly that it looks like it does have less energy by relative comparison to the first little BB running fast. You can sort of understand that if I'm losing 25% of the energy as I travel, that now this last thing is going to look really lame, where it should have looked much more energetic. And then you would get the idea that, oh, I see that all the really fast thing is also creating something that's still moving half the speed. But because of the way they did the experiment, it was moving 1/8 of the speed. All right, anyway. With a minimal amount of momentum transfer due to friction, etc. So, of course, this wasn't a minimum amount. These experiments had a huge amount of losses to friction. All right, for these videos, knowing the first object's velocity and mass and the second object's mass, you will slightly underpredict the second object's velocity. No, you'll overpredict it. So you didn't even say that right. You will slightly underpredict the second object's velocity. No, you're going to overpredict it. You're going to think it's 100% when no, you didn't do 100% transfer. You're going to predict a certain outcome if there's no losses. The outcome will be all of the momentum goes into the object. But the fact is the two train, the coupled train that weighs twice as much won't be going. If the first one was going 10 miles an hour, it won't be going 5 miles an hour. It'll be going 4.8 or 4.7 miles per hour. You have to use the momentum for the losses. The losses have to come out of your momentum. You can't have the momentum transferred and make some toast. You can't do both. Okay, the second object's mass. You will slightly underpredict the second. It's like, look, the boulder example with the catapult. If I catapult the boulder and then the boulder hits a duck, okay, tragically, Then when I catch the boulder, it's not going to push the spring down as far because it actually did lose some momentum. It lost some energy to smushing the duck. Duh. I can't 100% transfer it and smush a duck. Okay. Obvious losses, but the prediction is tight. Well, this is I'll just say that's a silly statement. All right, this is a long sentence here. From these videos, knowing the first object's velocity and the mass of the second object, you will slightly underpredict the second object's velocity. So you're overpredicting, blah, blah, due to obvious losses. So again, they're not always obvious, but regardless, I mean, vibrations in the plastic, lots of them are not too visible. But the prediction is tight. So it isn't tight. Why would you say it's tight and there's a bunch of losses? And clearly you could see it in the video. I mean, there was huge losses when they had more than one object bouncing around. However, when doing the same with kinetic energy, the prediction for the second object is twice as large as the actual velocity, resulting in the heavy object having more speed than the lighter object. So that's really not the prediction, but regardless, I mean, obviously it's saying that somehow the lighter object has twice as much speed. So it's pretty much saying, if I can just reverse the experiment, okay, that is, I take the energy of a heavy object, okay, compress a spring with the heavy, slow object, then put a light object and have the spring release it, I'm somehow making energy. Again, that's the paradox. Clearly, the kinetic energy formula is not telling you the truth. It's telling you a preposterous lie that somehow you can make free energy by merely having fat people sit on chairs and then put kids on the chair, and the kid will fly off with twice as much energy. That's literally what they're saying. That's the literal implication of the formula. If people knew enough about physics back when this was argued in France, obviously somebody could just make that point and say, you're just saying that, okay, I put a fat person on a spring. Okay, they compressed the spring. Now I put a kid on the spring, and the kid now made extra energy. If I catch the kid, he'll have more kinetic energy than the fat person could possibly produce. So I'm making energy. I don't need nuclear power plants. I don't need to, melt. I don't have to go out and slaughter whales and put fuel oil into my lamps and all this kind of crap. I can just make energy, watts and watts of energy, just by having fat people sit on chairs and then putting the light kid on there to get shot off the chair. All right, so I'll read this guy's comments, but you're just about done here, fella, okay? Because you keep saying things that are clear in the videos, and this idea that you think I'm going to rewatch the video in timestamps is just ludicrous. If you're going to do comments, you can't make a video, you can't make you can't articulate your argument and show it with pictures or do any of that stuff. That's your limitation. You've decided to argue that way. All right, but you can't do this quote mining crap where you expect other people to replay a video, okay, to counter argue. I'm not doing that. All right, you have to be able to quote people. You put it in. There's things called quotation marks. You put the other person's statement in quotes, and then you argue how that statement's wrong. You don't oblige them to go somewhere to see the quote. No, we don't know it goes twice as fast. So we do know it, and it's the premise of the argument. So again, in the physics girl example, it was stated as a premise of her argument. Her premise was we 100% transferred the momentum. 100% transfer. And then she said, but we lost half the energy, and that's okay. You can lose half the energy and have a 100% transfer. You can completely transfer the momentum and you can lose half the energy and it's no problem. That statement makes sense to them. It's insensible nonsense. All right. When you proved it, when you proved it will go twice as fast, give me your proofs. So again, I don't have to. It's the premise of the thought experiment. It's something she overtly said is a fact. Now, it is easy to prove, but I'm just saying it's overtly stated as a fact of the experiment. I don't have to prove it. She's stating it as a fact. Ask her to prove it. Okay, the laws are the experiments you use to come up to this conclusion. This begins from your assumptions. So there's none of my assumptions here at all. This is just your preposterous notion that you can 100% transfer the momentum, but you can lose half the energy at the same time. That's insensible baby talk. Okay, that they will have the same momentum, but you can prove that they will have the same momentum. Of course not. So again, I don't have to prove it, and I can prove it. I can just show you that marble experiment. I can show you 100% of the momentum being transferred, and there doesn't look to be any huge sparks flying around. There doesn't seem to be a whole bunch of energy going everywhere. I don't see anybody making extra toast. I don't see any of this kinetic energy formula being real. What I see is momentum is real. Okay, you don't do any experiments, you are lying. So again, I'm not going to accept that. I'm not going to defend myself against it. The whole point is there's millions of scientists out there. You've been doing this for years. The only experiments you're going to show me, the only experiments shown in the whole argument that started this nonsense, the only experiments shown to defend this nonsense were shooting balls into gravity and dropping them into clay. You're saying clay tells everybody the truth. How far something goes into clay tells you how much energy it has. It's a perfect ruler. It's an energy ruler. A piece of clay is an energy ruler. And the deeper the object goes, the more energy it has. That's your argument, because that's the only thing that'll work. If you use a spring, that's not what's going to happen. If you use a crossbow, that's not what's going to happen. If you use a catapult, that's not what's going to happen. If you use two magnets, that's not what's going to happen. So instead of showing all those experiments, you just looked at one experiment and said, I'm going to cheat the truth. And that's all you're doing, is cheating the truth. You think clay is a good ruler. I'm arguing that clay has a huge bias for velocity, just like brain tissue and other substances. The faster you go through it, the less you have to hit. All right. No, it's not a fact. You're just a wrong assumption. So again, I'm not going to replay the video. Are you really this ridiculous? You think I'm going to play the video to hear my own quote so I can respond to it? So you're too stupid to even understand that little bit of civility. That you really do that. If I put 17 timestamps in a video, you actually click on the timestamps to actually hear what the person said, so you can see how brilliant this sentence is that doesn't even have a period in it. Yes, sorry, or a capital letter. All right, anyway, so 37, the lighter body don't go twice as fast. So who believes that? Who believes that if I put two arrows, I have two arrows, one's twice as, they're the same size basically, and one just is twice as heavy. Made out of, one's made out of steel, one's made out of aluminum, twice as heavy. His theory is I put the same crossbow, the same tension, same pressure, and he says he doesn't believe the fast one goes, the lighter one goes twice as fast as the heavy one. Of course it does. No, at your board is some silly drawings of your assumptions. So again, he's just calling them silly drawings when they're exact illustrations of exactly what's claimed in the videos. So should I just say that anybody who draws on a board is silly? I mean, they use little cutouts, a little train cutout. Should I just pretend that doesn't mean anything? I mean, you don't like illustrations? You don't think illustrations are a hugely valuable component to understanding? So, but to imply that I've cheated somehow, well, you've never shown it. I asked for the direct, show me how I cheated their argument in some way. Well, you don't show it. I mean, so that's just, you're just lying. You're impugning my presentation without any evidence at all. You're not showing how the presentation was inaccurate, false. I made some claim that isn't true. What claim did I make that isn't true? Okay. I mean, even some of my, well, anyway, less directly evidence claims about your character seem pretty reliable now. The lighter bio don't go twice as fast. Again, you never proved it go twice as fast. So again, these are experiments that have been done. So it's just silly to say if I have a BB gun and I pump it up with air and it has a certain amount of pressure, and I put a BB in that's twice as heavy as the other BBs, that BB leaves twice as slow. I mean, we've all done these experiments over and over again. Silly drawings. If you've done any, give me your measurements. So again, the measurements are in these experiments. I have shown an awful lot of videos. Again, it's not my fault that these explicit experiments aren't done by educators, because clearly the educator doesn't want us to be stuck drawing a paradox on the board. He doesn't want to say, look, it has twice as much energy, but we can't collect it. Because, when I take that thing that has twice as much energy and I hit it into a spring, it compresses the spring the same amount as the thing that has half as much energy. See, so I can't collect this fake, phony, bullshit energy I'm claiming there exists. So obviously they don't do the experiment because they could never explain it. They could never explain why they're arguing for something that just plainly isn't true. Uncollectible energy is called nonsense. If you can't collect the energy in any experiment in the universe, that's called a fake thing. Okay, when you can never collect it, it's fake. Yes, Newton's second law says that they will not have the same momentum. So again, he's saying Newton's law says so, when that is a complete lie. Newton never said it. Newton would never endorse it. For you to take on Newton's identity and claim what Newton says, Newton would hate your formula. He would hate it. Okay, with an insane passion. If I could dig up Newton and reanimate him, he would spit in your eye, fucker. No doubt about it. He would have no use for your nonsense energy. Okay, if you don't know that Newton's second law says is your problem, read it. So again, there's zero evidence that there's anything in Newton's law in F equals ma that says square the velocity. There's nothing in that statement that says the velocity is twice as important or 4 times as important. Nothing. Okay. Deforms the spring. Go see that deformation energy is before you talk. So again, he thinks the spring deforms in some not coherent to momentum way. Just like the bow. All the deformation in the bow is in the direction of the momentum, the pressure it's going to give. It's not doing a lot of deforming in energy. It doesn't deliver energy in anything but one direction. Okay, it really is coherent to the direction you want to get the energy out in. So it's not making a bunch of deformation energy. It's not shooting energy sideways in all kinds of other directions. So you're the one who needs to understand what the word means, idiot. Deformations are where you're changing the direction of the energy. You're losing it to a misdirection. That's deformation. Deformation isn't where the shape changed, but all of the energy goes in one direction. That's not deformation, idiot. Okay. Deformation energy is before you talk, but if the name is your problem, the official name is elastic. So again, he's using, there's some official word called elastic. There's no such thing, as I pointed out. Elastic is absolutely meaningless. You're just talking about whether or not an object is able to carry, that is, transfer momentum. And some things can and some things can't. Just like some mediums transmit sound, but some mediums won't transmit sound. Like a bucket of sand is really shitty at transmitting sound. Okay? There's no point in sitting there and say, well, that's inelastic. There's no point in calling that something. All right, potential energy, and its potential energy stored as a result of deformation of an elastic object. Again, excuses just to avoid the fact of what you are saying is wrong. So let's all understand, they call it a bag of elastic bands, right? Even though they're inelastic bands. So we know this word is horseshit. It doesn't really mean anything. They've confused it to hell. So don't sit there and tell me, oh, we have this really precise language we use. Why do they call it an elastic band then when it's completely inelastic? Okay, anyway. Yes, Newton's second law doesn't say you lose half the energy. Okay, so Newton's second law doesn't say you lose half the energy. So you're agreeing now? Just doesn't make any sense, right? I'm showing right where they illustrate it. The formula says the coupled trains lost half the energy. That's what your formula says. It's not what Newton said. Okay. This why it agrees with conservation of energy. No, it agrees with conservation of momentum. Newton thought energy was momentum. So don't keep lying about what he thought. He didn't think energy was 1/2 mv squared. He thought energy was mv. Okay, it's just say that your assumption that they have the same momentum is wrong. So I don't even know how to make any sense out of that at all. One minute he says, yes, they have this. The law doesn't say you lose half the energy, and the next minute he says, yeah, you lost half the energy because the momentum didn't stay the same. You can't conserve the momentum, that is, transfer it successfully, and then say I lost energy. It's just retarded. All right. Yes, Newton was right. They will not have the same momentum. So again, all of these experiments are really talking about where you have the same momentum, and you're claiming one of them has twice as much energy. So I don't even know how that could be applicable to anything I said. That's what Newton's second law says. Read it. So he just says the same thing over and over and over again, as if Newton's second law says square the velocity and cut the mass in half. It doesn't say that. No, it doesn't say it will have twice the energy. Your formula says it has twice the energy. It's explicit. Okay, if I do the calculation for the single train going 10 miles an hour, all right, and then I do the calculation for the double train going 5 miles an hour, you say the single train going 10 has twice as much energy. That's explicitly true of your formula. That's what it predicts is the truth. And I'm merely asserting there's no experiment ever conducted on Earth that ever collects that difference, that ever shows that difference, that ever creates a catcher's mitt to catch the two balls, right? I throw a heavy baseball, okay, 10 miles an hour, and I throw a ball that weighs half as much, 20 miles an hour, and I catch them in the same glove. There's no glove on Earth that will be able to catch those two balls and say, yes, the one that was going 20 miles an hour had more and twice as much energy. No catcher's glove in the world will catch that extra energy, except a lump of clay. So fuck. There's just no point. They just don't care. They don't care what the history is. They don't care how bad the experiments were conducted. They don't care how bad this physics is. They're just going to keep defending it, even though it's just overtly wrong, insensible nonsense. They're just going to keep doing this, right? This is the human race. They will not be educated. They will not give a shit about the truth. They will not give a shit about facts. They're just obstinate religious kooks. I mean, the whole fucking world is just covered with lying sacks of shit bullshitters selling a stupid bullshit narrative. They want to believe in pixies. They want to believe in fairies. They want to believe in UFOs. And so they contrive lies and nonsense to defend this crap as having some sort of credibility. It's disgusting behavior. Anyway. No, it doesn't say it will have twice the energy. Of course it does. Overtly. The math says that will it not have the same momentum. So exactly the opposite is the truth. Okay, the momentum formula can't be fucked up. MV can't be screwed with. All right, so you're just that's just overt nonsense. Okay, but they will have the same energy. So again, just absolute nonsense. Your formula says they have opposite energies. You're just bullshitting. You're just full of shit. You're just a liar. You're just a sack of shit. All right. And you're pretty much going to be done here because you don't premise your arguments with any facts. You don't show any experiments. You show nothing. Okay? Just absolutely nothing. Oh, we can go to the NASA site again now because it's working again. And I'll just show how there's no MV squared on the page. It has nothing to do with moving spaceships, maneuvering a spaceship in space. Okay, so just to prove the point. that it has nothing to do with the assertion NASA might have opinions on lots of different subjects, okay? I'm talking about landing on the moon, what math they used to decide how much thrust to maneuver their spaceship with. And those things were decided clearly by momentum. All right, anyway. So yeah, we'll just remove that crap. All right. Oh, what did this say? He is bullshitting so much, it's really hard to fathom. So you'll show no bullshit, you'll give me no evidence of the bullshit, you'll never show me the experiment collecting the extra kinetic energy. Show me one experiment where you show that the faster, lighter train has more energy. It will, in fact, light a light bulb longer. It will, in fact, produce more heat. It will, in fact, produce more anything. Show me one single experiment proving that the lighter object has more energy, the lighter faster. Show me one experiment verifying. One, just one. All right. And they won't do it. Not only does he not understand any of the laws, so I clearly do understand them, okay? I clearly understand who Newton was and when Newton was, and I understand that all this bullshit was way after Newton, and it had absolutely nothing to do with Galileo, Descartes, or Newton, okay? It's opposed to all of those foundational experimentalists, and it was invented by silly people, frankly. Just plain silly people created the energy for this new religion of the living force. Let's understand, it was called the living force. Real scientific, huh? But he thinks he is qualified to say, no, I'm qualified because I actually have paid attention. I've actually read the, pages and pages of transcript and of arguments that have been made. I'm the one who's read the historical record. You're the one who doesn't give a shit about the truth. Okay, that this is all some sort of semantic error. So amazing. Getting completely different energies, completely different numbers. 2 + 2 = 3. Oh, well, that's a semantic error. It's the same as 6 or 4. What do we care? They're all the same, aren't they? Doesn't make any difference. So I mean, amazing. And then he glibly pretends he's resolved everything in his mind. Well, I clearly have a coherent understanding of reality. I don't keep two notions. I don't sit there and say it makes perfectly good sense to have two completely different formulas describing exactly the same thing, and get completely different answers with the two formulas. I know that doesn't make any sense. And if you believe that does make sense, you're the one who's delusional, clearly. All right. In a previous video, he wrote F = m times v. Yeah, just like the crash course woman understands, that's exactly what Newton was basically saying. Acceleration, you do understand, don't you? That acceleration always has to be converted into velocities. It's made of velocities. When you try to figure out what something's acceleration is, you really calculate what its velocities are. Okay, it's velocities now, it's velocity in a minute later. It's made of velocity, dumbass. Jesus, you stupid fuck. What more to say? It is obvious that he has no idea what Newton's law says. So again, why don't you write that comment? Go over to the Crash Course PBS video, and why don't you write that comment and say, this bitch don't know what she's talking about. Okay, she said Newton says it's about velocity. No, he didn't. Newton didn't know acceleration was velocities over time. Yeah, Newton did know that, asshole. Oh, man. So this idiot's on once again Wheeler videos. It's not gravity, it's buoyancy. Oh, God. Fuck this planet. Alright, anyway, I was going to show the other. Oh, here's the NASA links. Okay, so we can go to this one. Right, so I asked for evidence that when NASA was, because the moon doesn't have any atmosphere, right? When NASA was figuring out how to maneuver its lander and how much thrust it needed to get it to go anywhere and all that kind of stuff, that there's no way it used the kinetic energy formula. There's just no way it used it, because it would get the wrong answer. It would give the the land or too much thrust, all right, or too little. And so I made that simple argument that if you want to navigate in space, you can't use this 1/2 mv squared thing, because it's not going to, it's going to give you the wrong answer. You're going to do things that are just plain stupid. You're not going to know that if I shoot 5 pounds of my spaceship that way at 10 miles an hour, or I do 10 pounds at 5 miles an hour this way, that somehow that way produced more turning power. Well, NASA knows that isn't true, idiot. Alright, so you can see here that it's a nice little page, blah, blah, blah. So it points out everything. W equals work, right? H equals entropy, Q equals heat flow, K equals kinetic energy, P equals pressure, W equals shift work, V equals volume, U equals velocity, E equals internal energy. Is there an M there anywhere? Not a single M. No M's. And you can go through all this shit and there's no M's. There's just no M's here anywhere. Right? No M, still no M's. Still no M's. There's an M here, okay? And then it's times U, which is velocity. And I assume, I mean, this is a NASA page and they don't even have it in, the formal script, which is kind of funny. So that's what they say the kinetic energy formula is. So that's the formula. There's still no M's when they use it. There's no M's anywhere in here except in writing the kinetic energy formula. So the only M on the page is the kinetic energy formula. The actual derivatives have no M's in them. No M, no M, no M, no M, no M, no M. Because guess what? They're really not talking. They're talking about volumes of oxygen and, of atmosphere. It's about a turbine, you idiot. It doesn't have anything. A turbine has to work in an atmosphere, you idiot. It doesn't work in space, you idiot. I mean, fuck. So clearly not on the subject. Has absolutely zero to do with proving that NASA uses the kinetic energy formula to maneuver the space station in orbit. So he hasn't proven that at all. And I'm quite sure that, like I said, if they are using it, they're going to crash soon, okay? Because it's not going to work. Because it doesn't give any right answers ever. It always gives you the wrong, well, not always. There are certain, like if I make the masses and the energies, the certain ratios, the kinetic energy formula comes up with exactly the same answer. But it's only 1% of the time. Do momentum and kinetic energy agree? All right. But anyway, enough of this nonsense. It's just pathetic. Pathetic. It's all pathetic. Yeah, so I'm done. Yeah, that's good enough. So, till the next time. And, there's a point where maybe I just give up and take a month off or something. Because you can't have a rational conversation with anybody on this planet. They're all idiots. So anybody who wants to attempt to, I'll try not to insult your mother. If you think you're competent to have a physics conversation where you can explain the history, you can explain how the Clay experiments are the truth, you can explain any of this stuff, that would be great. But I'm sure no one's going to volunteer because I can't even pay people to have the conversation. Right? But, what can I do? I can just solicit your capacity. See, because these guys just keep evading the points I make. I make these explicit points and they keep running away. They never answer the point. How is it possible to transfer 100% of the momentum and also make toast? Create heat or create sound or create anything. How is that ever possible? Show me ever that happening on planet Earth. Because it can't happen. If you lost energy to the environment, then you lost momentum. You can never change the environment and transfer 100% of the momentum. You can't do it. It's impossible. But they won't answer that simple point. And the only way you can get them to do that is if you have them in a conversation, because then you can just say, you just change the subject. Just answer my question. How is it possible to transfer 100% of the energy and then say, but I also had energy to do all this other stuff? How can the boulder go through the air, okay, and then in the middle of the air, say it does something. What does it do? Trying to think of something more benign than hitting a duck. But again, it can't have some interaction. I mean, it can't have an affair with somebody's wife or do some other kind of thing and then come back and have the same momentum. It can't do something and then still have the same momentum when it lands. It can't do that. So, till the next time and such, and so forth and whatnot. Alright, this has been a DraftScience video presentation.